Welcome. In this video, I'm going to explain the basics of understanding indirect effects or statistical mediation analysis in a simple mediation model involving one predictor, one mediator, and one outcome variable. So indirect effects are used to explain the process whereby one variable may influence another. So some examples of questions that we might use a mediation analysis or analysis of indirect effects to answer is the relationship between physical exercise and self-confidence explained by physical attractiveness? So let's say exercise improves self-confidence, but is the reason, or is at least one of the reasons that it improves self-confidence because of an increase in physical attractiveness? So that would be an example of a simple mediation model where we have the x variable in theory impacting the mediating variable, which in turn is in theory impacting the outcome variable, and we're asserting that the mediating variable, at least in part, explains that relationship. So we're really talking about at least proposed causal chains. Another example is the relationship between intergroup contact and prejudice reduction explained by reductions or changes in intergroup anxiety. So as people have more contact with an outgroup, a group they don't belong to, their level of prejudice towards that group is likely to decrease. And this is asserting that the reason for that decrease is because of reductions of anxiety when encountering the outgroup. So we have to keep in mind, though, that you should have a sound logical or theoretical basis for making the assertion of the causal claim, or of the temporal precedence, rather, temporal precedence of the variables. So what I mean by temporal precedence is that you should have some reason to claim that the changes in the x variable lead to the changes in the m variable, which in turn lead to the changes in the y variable. So over time, the process unfolds the way that you are claiming, or that you're setting it up to test. Because unfortunately, you could have a really solid statistical mediation model that just doesn't make sense in terms of the logic, in theory, and the temporal precedence of the way the variables are likely to unfold. So we have to keep in mind that, especially when an analysis is correlational, it's usually not sufficient evidence to make causal claims. Even though we're testing a proposed causal chain, if all the variables are measured, we really still need to be cautious about making strong causal claims with our results. So as I've already noted, we want to be sure to take into account the likely temporal precedence of our variables. So changes in our x should be thought of as leading to changes in m, which in turn should be thought of as leading to changes in y. Another thing to be cautious about when conducting or interpreting or consuming research involving indirect effects is the degree to which the variables are tautological. So if they're basically measuring the same thing with different labels or names, or slightly different operational definitions of the variable, it might fit nicely in a mediation model, but it may not contribute very much to the science. And then also another consideration is sample size. So sample size does need to be relatively large for these sorts of analyses, or it's nicer when it's much larger because you have more power to detect the effects. It really depends on the size of the indirect effect. It depends on also the size of the paths that make up the indirect effect. So we're usually talking several hundred participants, unless the effect sizes are relatively large. With very small effect sizes, we're talking usually at least 500 participants, although with medium effect sizes, we can get away with uh, less, although most studies involving indirect effects will have several hundred participants involved. So let's look at the paths in a simple mediation model. So here we have an IV. You could also think of that as the X variable. And we have the DV, which we can also think of as the Y variable. And we have M, which is the mediator, but can also be thought of as another X variable, let's say X2. And we have these paths. So let's look at the first path is A, which is a regression using the IV or X to predict the mediator. So that's establishing that link in the causal chain in the proposed model. And we have the B path, which is looking at the relationship between the mediator and the DV or the Y variable while controlling for the IV or the X variable. So it's important to note that this B path is controlling for the IV and looking at the coefficient of M predicting the DV. We also have what's called the direct effect, which is the relationship between X and Y, or the IV and the DV, while controlling for the mediator. So just to reiterate, the A path is a simple regression with X predicting M. The B path is M predicting Y while controlling for X. The indirect effect can be thought of in two ways. Probably for me, the simplest way is it's the product of the A path times the B path. That's the indirect effect. Basically, the extent to which the IV-DV relationship or the XY relationship is explained by the mediator. We have the C prime path, which is also known as a direct effect, which is the relationship between the IV and the DV, or X and Y, while controlling for M. And then we also have what can be called the total effect, which is if we ignored M, the relationship between X and Y, or the IV and the DV. So you could do this sort of mediation analysis, using path analysis and SEM programs. But for this introduction to this, we're going to use an OLS approach, or ordinary least squares regression approach, to testing indirect effects. Now, the old school way, there was kind of a way that had been done for at least a decade, actually probably more like a decade and a half, which was the Barron and Kenny approach, involved testing multiple steps. So first, a researcher or data analyst would test the relationship between X and Y to make sure that the relationship between the IV and the DV existed in the first place, that there was something to be explained. Then the researcher would test the relationship between X and M, or the A path, and then the B path, the relationship between the mediator and the outcome variable controlling for the X variable. And then finally, the researcher would investigate the difference between the C path and the C prime path. So to see if basically the direct effect dropped to non-significance. So if the total effect was significant and the direct effect was not significant, the researcher would conclude that there was mediation. That's kind of a pretty high bar to pass. It's basically demonstrating complete mediation instead of partial mediation. And in many situations, the relationship between a given predictor and outcome could be explained by multiple mediators. So it's maybe a too much of a high bar to pass to have to completely explain the relationship between X and Y. So more modern approaches don't require that. But we should note that the difference between the total effect C and the direct effect C prime is basically the indirect effect and equal to the product of the A path and the B path. So ultimately, that's what we're trying to test, but um, more modern approaches have been developed to test the significance of the indirect effect. Now, most of the paths can be tested using ordinary least squares regression and the usual standard errors. However, the sampling distribution of the indirect effect requires special considerations. And there's a few ways to approach how to test the significance of the indirect effect. Uh, and several procedures exist, but bootstrapping is the one that's most widely used and recommended. There's various types of bootstrapping. We're going to just talk about the most straightforward one, which is the percentile bootstrapping method. So, what is bootstrapping? It's a resampling strategy that we use to estimate population parameters and their confidence intervals, especially in situations where the assumptions of the usual way we would do things are not met. And this happens to be the case for indirect effects because it turns out that uh, the, the, the usual assumptions of normality are not met. So when conducting bootstrapping, well, a computer does this. A person doesn't actually do this because it would take forever. But you would repeatedly and randomly take a large number, usually 5,000 samples of size n. So whatever your sample size is, let's say you had 200 participants, you have data for 200 participants, you would take 5,000 samples of 200 participants with replacement from your observed data. So it's important to note that it's with replacement because if it was without replacement, you would just get the same statistic every time you resampled. But because it's with replacement, there's a potential that you might, in any given sample, select the case multiple times or not at all. And then after you calculate whatever statistic you're interested in, here we're interested in the indirect effect, you calculate it 5,000 times, and then you can determine the confidence interval using the percentile ranks. So basically, with the percentile method, you're looking at the 2.5 percentile rank and the 97.5 percentile rank as being the boundary of your confidence interval for the statistic you're looking at. So here we're talking about the indirect effect. So we look at the confidence interval of the indirect effect, and we can examine size of it, and we can also examine, does it exclude zero? If it excludes zero, we can rule out zero, especially if it excludes zero by a wide margin. We can be confident that we can rule out the null hypothesis of the indirect effect equaling zero. We can also look at how narrow it is. So if it's a more narrow confidence interval, it's more precise. If it's wider, it's less precise. If it's wider and it narrowly excludes zero, we might not be as pleased with our claim of having an indirect effect as if it was narrow and excluded zero by a larger margin. So there are extensions and related analyses. So the simple regression basics that we just went over can be extended to more complex models. So, for example, parallel mediation involves having multiple mediators where you don't uh, assert a temporal order for the mediators. They're more or less entered into the model simultaneously, and you could compare their relative importance. Serial mediation models involve having multiple mediators along the causal chain, but you assert the temporal precedence of the mediators. So X would lead to the first mediator, which in turn would lead to the second mediator, and so on. There's also moderated mediation and mediated moderation. Moderated mediation involves looking at the indirect effects change across the levels of another variable. So is there a, a another variable that impacts the strength of the mediation? And mediated moderation involves an interaction effect that is explained by a mediator. As things get more complex, you can use path analysis, so you can have more than one outcome variable. You can have serial mediators, you can have parallel mediators, you can have serial and parallel mediators. You can have parallel mediators that are in sequential order, so things can get considerably more complex. And then you can use structural equation modeling, where you can model latent variables and use observed variables to model latent variables and attempt to account for the error in your measurement and create models involving indirect effects of latent variables. So this is kind of simple mediation analysis is a good point of departure for many more complex analyses that can be viewed as extensions, or at least related to uh, mediation analysis. So let's go ahead and test one of these analyses using Hayes process macro. So a simple mediation model in Hayes process macro is model 4. So that's going to be the model we're going to test. So I have a data set here with a bunch of variables, but I want to focus on the first three, which are political efficacy, political aversion, and political engagement. So what I want to test is to see if the relationship between political efficacy or confidence to participate is related to political engagement, which I'm pretty sure it is. And perhaps more interestingly, is that explained by dislike of politics? So, does political efficacy one's confidence to participate in politics? Does it cause one to like or dislike politics, which in turn leads one to be either more or less engaged or disengaged with politics? So I'll go to analyze, and I've already installed the process uh, dialog, custom dialog, by going to extensions, utilities, and install custom dialog, downloading the custom dialog file from processmacro.org. So that's already installed, but I'll go to regression process. I'm going to make sure that I select the correct model, which we identified as model 4. And my outcome variable for that example was engagement, so that'll be the Y variable. My predictor, or my initial predictor, was efficacy, and my mediator was aversion. And I'll leave the defaults for the most part. 95% confidence interval, 5,000 resamples for the bootstrap. You can also select for it to bootstrap all of the coefficients, not just the indirect effect. But for this example, we'll just leave it as is. Under options, we could ask for the standardized coefficients instead of the unstandardized coefficients, and we could ask for some effect size options. but I think we'll leave for this first go at this. We'll leave the default options in, and we'll click OK, and it's going to do the analysis 5,000 times, or at least calculate the indirect effect 5,000 times. So we'll give it a moment to do all that work, and it looks like it's nearly done with the work. So the first bit of information gives us our variables, so we want to make sure that that's correct. Our outcome is engagement, our predictor, our initial predictor is efficacy, and our mediator is aversion. It gives us our sample size, and then it gives us the first model with aversion as the outcome. So that's our mediator as the outcome. We can see that we're predicting about 20% of that because that's the R squared value, and that model is significant. The coefficient for the A path here is 1.96, which, just like the model, is obviously significant. And then we have the outcome variable, political engagement. So here we have the relationship between political efficacy and political engagement while controlling for political aversion. So that's our C prime path. And we also have our B path, the relationship between aversion and engagement while controlling for efficacy. And we see that our direct effect, or C prime path, is actually just not really significant anymore after we throw in the mediator. So that's kind of a good thing if we were wanting to have a strong mediator, that it basically wipes out the effect of the IV when they're included in the same model. And we see that the confidence interval for that also now includes 0. And we have, for political aversion, we have a significant, but it's hard to tell because these are unstandardized coefficients, but somewhat weak, but it definitely excludes 0 and is statistically significant. And then we have the direct effect, so that would be the relationship between political efficacy and political engagement, just in a simple regression analysis. I mean, rather, that's actually the relationship we just looked at. That's the direct effect is the relationship between political efficacy and political engagement while controlling for political aversion. So that's the relationship we looked at here, and that one includes 0 and has the same p-value. So it's just redundant information, but it's better labeled there. And then we have probably what we're most interested in, which is the direct effect, which tells us that the lower level of the confidence interval is 0.03 and the upper limit is 0.09. So it does exclude 0. And we can conclude that there is a indirect effect whereby political efficacy impacts political engagement through dislike or political aversion. So that is basically how you run a simple mediation analysis using Hayes' process. I hope that this helped to foster your understanding of mediation analysis. Things can get much more complex, and at first pass, some of this is new material and new language to learn, but most people can master it after fighting or struggling with it for a little while. Thank you for listening. I hope you enjoyed that as much as I did.